Assalamualaikum and good day everyone. So today you're going to learn about mass spectrometry. So this topic will be in chapter 5. So basically, what is a mass spectrometry? Okay, so this is a kind of instrument that accurately measures the mass of different molecules within a sample. So basically, mass spectrometry will be used to identify molecules in a mixture, detect impurities in a sample, analyze a purified protein, and also study the protein content of a sample of cells. Okay, so as you all know, mass spectrometry based on the ionization of gas phase molecule followed by analysis of the masses of the ions produced. So basically, the concept of mass spectrometry involve ionizing a compound. So from this ionizing compound, there will be a process of separation uh, of the ions. Okay, and basically, um, the parameter that we use in this instrument is mass to charge ratio, which is m per Z. Okay, so this is always become the important parameter in order to determine the exact compound in the sample, molecular ion peak. Okay. Okay, so this is the setup or arrangement for the mass spectrometer. So basically, the sample will be injected, okay, into the inlet system, and then it will passing through the ion source, okay, with a certain value of pressure, and it will go to the mass analyzer, and the final part is detector. So basically, in this process or this compartment, starting from inlet system until detector, it must be conducted in the vacuum condition. Okay, why we use a vacuum condition? Because we want to reduce collision between ions and gas molecules. Okay, so basically, that is the thing that will happen when you run the mass spectrometer. So we want to avoid any collision. Okay, so that's why we use vacuum system. Okay, so after the ion molecule passing through the detector, and then it will go to the signal processor, and then it comes out as an output. Okay, so you will get the result as a spectrum. Okay, so basically, in the inlet system, the sample will be vaporized. Okay, and when it comes to the ion source, the analyte will be ionized. Okay, and when it passes through the mass analyzer, it will separate ions according to the ratio of mass to charge. Okay, so in the detector, it will count the ions. Okay, how much the ions will be detected. Okay, so um, uh, that part will be in the detector compartment. Okay, now we go for the process in mass spectrometer. So in mass spectrometer, it involves ionization process, and then acceleration, next dispersion, and the last one is detection. So for the first one is ionization. In any mass spectrometer, ionization process is very important because if the analytes or the molecules in your sample is not ionized, and so the process will disrupted, and you cannot detect any molecule in the output. So the first step is very crucial, and this process is ionization. In the ionization, the atom or molecule is ionized by knocking one or more electrons off to give a positive ion. So basically, when the molecule receives sufficient energy, so it will remove one or more electrons from its atom. Okay, so when the electrons remove, so it will give a positive charge ion, okay, in the molecules. Okay, and then next is the acceleration. The ions are accelerated so that they all have the same kinetic energy. So in this part also very important, because as you all know that the parameter that we try to control is the mass over charge of ion. Okay, so basically when we have this ratio, so basically it will affect the mass. Okay, so uh, in the acceleration part, the kinetic energy must be similar for each ions in the sample. Okay, so that the acceleration will be equals, just vary at the mass of the ions. Okay, so next is the dispersion. In this part, the ions are then deflected by a magnetic field according to their mass. Okay, the lighter they are, the more they are deflected. Okay, so in this case, you must know that uh, the parameter that we try to control is the mass of the ion. So when you have a lighter mass of ion, so uh, this ion will become more deflected. Okay, will become more deflected. Okay, compared to the heavier one. Okay, so we go for the last process, is the detection process. So in this process, the beam of ions, after passing through the mass analyzer, okay, it will passing through the detector. Okay, so after after the detector counts the ion which it's received, it will transfer the count into electrical signal. Okay, now we go for the ion source. So in ion source, we have different kinds of ion source. The first one is hard ion source. So this kind of ion source will leave excess energy in molecule, so that you will get extensive fragmentation in the output. And next one is the soft ion sources. So in this kind of ion sources will have a little excess energy in molecule, and it will reduce the fragmentation. And this is the list of ion sources for molecular mass spectrometer. And you can see that we have a variation of name according to the either it's a gas phase or desorption. So in this of ion sources, for example, the first one is electron impact. Okay, so for the electron impact, the ionizing agent is the energetic electrons. Okay, so next one is the chemical ionization. The ionizing agent is the reagent gases ions. Okay, so we have a variety of ion source. Okay, and what is the ionizing agent? So now we go for the gas phase ion sources. Okay, so the first one is the electron impact. Okay, and the second one is chemical ionization. So for the electron impact or EI, okay, so basically it does involve a hard ionization vapor phase sample molecules are bombarded with high energy electrons. So after this bombardment, it will cause the molecule become unstable, so it will become the radical cation. Okay, so you can have a look at this chemical reaction. Okay, starting from the molecule, it will receive enough energy of electron, and then the electron will remove from this molecule, and after that it will become unstable and then it will produce the radical cation here. So after that it will become the radicals and cations. So in this case, the fragments that being detected is the cation, not radical. Okay, so this cation will be detected. Okay, so you can see um, in your output or in the spectrum that this cation uh, will be detected, okay, in the mass spectrometer. So basically ionization potential of typical compound less than 15 electron volt. Okay, so extensive bond breaking occurs resulting in smaller cations and radicals. Okay, so that is for the electron impact. Okay, so this is an example of electron impact in mass spec. So this is one example, the benzamide. Okay, so benzamide will produce will remove two electron here, so it will become the radical cation here. Okay, the radical cation, and then after that it will become fragmented. Okay, and then it will produce different two different things. Okay, like this one, this is a cation, and this one is the another cation. Okay, after the cleavage occurred. Okay, and then from this m per z equals to 105, this structure, it will remove the carbon and oxygen in this structure, and then it will produce more stable cation. Okay, so with the m per z equals to 77. So that's why in the peak you will observe 77. This is represent this structure. 105 represent this structure, the bigger one. And then we have also 44. 44 is this one. Okay, this another cation after the cleavage occur. And then this is a 1 to 1. This is the ion molecule 8. Okay, okay, so basically when we use the electron impact, so this method is well understood because we implement the basic concept of bombardment of electron into the sample, and then this method also can be implemented to all volatile compounds. Okay, so if your sample is not volatile enough, so you need to make sure that you need to do a product treatment, okay, before you can run by using spectrometer. Okay, just to make sure that it can become volatile when you uh, inject your sample in the mass spec. Okay, and then the fragmentation provides structural information. So actually from the mass spec, you can elucidate the molecule, okay, elucidate the molecule and guess what is the molecule in the sample. Okay, okay, so this method also have libraries of mass spectra. Okay, so you can use the libraries, okay, to identify the EI mass spectral fingerprint, okay, just to make sure that you know what is the analyte in the sample, okay. By the way, any instrument will have a limitation, so you must know that for the mass spec, the sample must be thermally volatile and stable. If it's not volatile and stable, so you must do a treatment, just like what I mentioned just now. And another point is the molecular ion must may be weak or absent for many compounds. Okay, so basically, when there is a weak molecular ion, basically it will not be detected and cannot be found in your spectrum. So this is the problem. Okay. Okay, so now we go for the second ion source, which is a chemical ionization. So for this chemical ionization, it is a kind of a soft ionization method, and much less bond breaking occurs than in electron impact. So basically, when you have a soft ionization method, so basically the fragmentation will not clear enough compared to the EI. Okay. So next, vapor phase sample molecules are mixed with reagent gas, okay, such as methane or ammonia. Okay, so the reagent gas molecules are ionized by electron impact, and then the resulting molecular ions of the reagent gas molecules react with the sample molecules. Okay, so here you can have a look at the chemical reaction. So R is the reagent, okay, S is the sample, E is the electron, okay, and the dot is the radical electron, and hydrogen is and H is the hydrogen. Okay, so basically you will see that the reagent first, okay, will receive electron. So it will receive a certain amount of energy so that it will become cation, okay, cation, a radical cation like this one, and it will release or remove two electron here. And after that, from this um, cation, radical cation, okay, it will have a reaction with the reagent, okay, and then it will form one radical and one cation. Okay, so here you can see that this RH plus will be detected in the mass spec. Okay, next the RH plus, okay, will react with your sample, and then it will replace or substitute the reagent. Okay, so in this stage the process is what we call a substitution reaction. Okay, so here you can see that your sample will replace the reagent. Okay, so that after that you can detect the signal. Okay, and it will shown in the spectrum. Okay, so after that, after you have this RH plus from the reagent process, the bombardment of reagent, okay, and then this will react with your sample, and then it will also become RSH plus. So this is a new cation, okay. So this also can be detected uh, in your mass spec, okay. So basically when you have a SH plus, this is the sample molecules. So this is actually the M plus 1, okay, the SH plus, okay. So this is not a radical cation, okay. So it is an even electron species and was not produced by excess ionizing voltage. And it remains relatively intact and doesn't fragment. So basically, when you try to compare between this and the EI, so you can see that in EI, there's another fragmentation process occurred, okay, when the radical cation produced, okay. But in this chemical ionization, there is no fragmentation, or we call as a cleavage, okay, process occurred when we use a soft ion source, okay. So that is a big difference between the soft and hard ion source, okay. So what is the benefit of a chemical ionization? So first one is often give molecular weight information through molecular like ions such as M plus H. Okay, so even when EI will not produce a molecular ion. Okay, so this is the typical structure. Okay, because it just give a slightly excess of energy. Okay, it required slightly excess of energy. Okay. Okay, so next is the simple mass spectra. Yes, because the cleavage or the fragmentation is not occurred uh, too many times. Okay, so it is a simple mass spectra, and the fragmentation also reduced. Okay, compared to EI. So in this, the limitation of this ion source, the sample must be thermally volatile and stable. Okay, so the same limitation when you use the electron impact. And the second point is the less fragmentation than EI. Okay, fragment pattern not informative or reproducible enough for lab research. So this is the limitation. Okay, so this is the limitation of chemical ionization. Okay. And the last one is the results depend on reagent gas type. Okay, so basically, the reagent must be inert. Okay, reagent gas, pressure or reaction time, and nature of the sample. So all of this is the parameter that need to be controlled when you use a spectrometer. Okay, now we go for the next type of ion sources. Uh, this is called as a desorption ion sources. So this technique is applicable to non-volatile or non-stable analytes. So basically, when you have a non-stable analytes and the sample is not easily volatile, then we can use this technique, desorption ion sources. Okay, so under desorption ion sources, we have two types of method. Okay, the first one is electron spray ionization, or in short form ESI, and the second one is fast atom bombardment, FAB. So now we go for the first kinds of ion source, okay, that implement the desorption process. So basically, for the electrospray ionizer, uh, this process implement the explosion of charged droplets that containing analytes, and this solution analyte pump through charge 1 until 5 kilovolt capillary. Okay, so the small droplets become charged, and after that the solvent evaporates, drop shrinks, and the surface charge density increases. So this is one kind of a soft ionization. So it will produce a little fragmentation. So in this figure, you can see the process that implemented by electrospray ionizer. Okay, so this is the capillary. Okay, in this capillary, it brings the solvent and sample. Okay, in this what we call as a nebulizer. So here we have the nebulizer needle just to make the pressure increase. okay, to make it become aerosol or small droplets of a solution. And we also have here the nebulizer gas, okay, the nebulizer gas, okay, and after it go to this area, okay, so this is the spray droplets, okay, so by the time it closer to the charge plate, it will fragment, okay, it will fragment into small cation molecules, okay, so it will passing through this capillary entrance, and then it will go directly to the mass spectrometer. Okay, now we go for the next types of um, ion source, okay, which is a fast atom bombardment. So this ion source is a kind of hard ionization ion source, okay, so it will give a more fragmentation, okay, in the output. So basically the sample will be in the glycerol solution, and this process involve a bombardment by the high energy of argon or xenon atoms, okay. So after that, the atoms and ion separated from surface. So this implement the ballistic collision, and then the charge, the ion charge produced, the M plus and M minus will be produced. However, this method only applicable to small or large unstable molecule. Okay. So next is the matrix assisted laser desorption ionization, or we call as MALDI. So this method is a kind of soft ionization, and the process involved is analyte is being dissolved in solution of UV absorber and solvent. Then solid crystals of analyte will mix with absorber to grow. Okay, so this is the matrix. Okay, in this case, um, and after that, the pulse laser fired at crystal in time of flight mass spectrometer, and after that, the molecular ion dissolved from crystal surface. Okay, now we go for the next compartment in the mass spectrometer, which is a mass analyzer. So the purpose of mass analyzer is to separate ions and to measure the ratio of a mass to charge, and also the intensity of the signal. Okay, so basically, we have a few kinds of mass analyzer. The first one is magnetic sector. This mass analyzer is not very sensitive, uh, but it does contain with high resolution. And the disadvantage of this magnetic sector, uh, it does require high technical expertise. Okay, so this is very expensive, and basically uh, these kinds of mass analyzer um, is equipped in the mass spectrometer for a certain purpose. Next is a quadrupole. Quadrupole as a mass analyzer does contain with does consists of a mass range in between 1 until 5,000, and and the sensitivity is very high. Okay, the quadrupole, and the advantage of quadrupole is easy to use. It's not very expensive, but high sensitivity. Okay. Next is ion trap. So for ion trap, it quite similar in mass range detection. Okay, with quadrupole, and it's also sensitive. Okay, and not very expensive compared to magnetic sector. Okay. So next we have a time of flight. Okay, so for the time of flight is the mass range is unlimited. Okay, so it can detect a big range of a mass range. Okay, so the resolution is about 0.0001 resolution. Okay, and it is very sensitive. And this mass analyzer is a simple design but expensive and a very high resolution. Okay. Next, we have the Fourier transform. Okay, for the Fourier transform, it does have the same resolution with time of flight and is very sensitive. Okay, and it required high technical expertise. So now we go for the first mass analyzer, magnetic sector. So this is the schematic process of analyzing sample by using mass spectrometer. So here we have a sample introduction, or we call as a inlet, sample inlet, and then it passes into the ionization source, okay, just to make it ionized, and then it will pass into the lens stack. So this will become the more focus, the ion will become more focused here. So next, it will pass through the magnet sector. So in this case, magnet sector, it will the ion that produced after passing through the ionization source, it will deflected. Okay, so deflected according to the mass. Okay, so the lighter the compound or the lighter the ion molecule, the more deflected the ion molecule. Okay, so here after it passes into the magnet sector, so it will being collected here in the detector, but before that it will passing through the collector slates. Okay, so it will be the signal will be more focused, and then the detector will collect all the signal. Okay, and after that it will passing through the computer to give the output. Okay, so in this case what you can see very clear is the using of magnet as the main compartment, okay, in the mass analyzer. Okay, as moving charge enter a magnetic field, the charge is deflected to a circular motion of a unit radius in a direction perpendicular to the applied magnetic field. So ions in the magnetic field experience two equal forces: force due to the magnetic field and centripetal force. Okay, so please have a look at the Google for these two definition, these two terms. Okay. So next we go for the quadrupole. Quadrupole for the second mass analyzer. Okay. So in the quadrupole, basically quadrupole comes from four. Okay, quad. Okay, quadrupole, and here you can see we have um, four rods. Okay, with a different charge here. Okay, so here you can see this is the positive charge, and this is the positive charge, and negative and negative. So from the ion that passing through the ionizer, okay, so it will go here, okay, ion beam, and then it will passing through the quadrupole. Okay, so after it passing to the quadrupole, in here the mass with different I mean the ion molecule with different mass will be separated according to the mass. Okay, so here you can see here this is the resonant ions. Okay, so it will after that it will passing through the detector. Okay, so this is the concept. Okay, from the source, and then it will go to the quadrupole and then go directly to detector. So in this quadrupole they need a current as a supplier. okay, as an energy supply. Okay, so basically this is the explanation, okay, the explanation of quadrupole. So basically this mass analyzer use electric field, okay, in order to separate the ions, and then the ions are ejected into a vacuum chamber that contains four parallel metal rods, okay. One pair of rods located opposite each other are positively charged, while the other pair is negatively charged. On top of the static positive and negative charge of the sets of rods, an additional plus-minus oscillation is also imposed on the rods. Okay, the combination of oscillating positive and negative field makes the ions in the vacuum chamber move in a spiral patterns. Okay, so basically, the ions molecule will move in a spiral pattern based on the charge that oscillate in the mass analyzer. Okay, at a given oscillation frequency, ions of either very large or very small mass spiral from the center and collide with the rods rather than reaching the mass detector at the end of the chamber. Okay, so this is the text explain about the process on how the ion accelerate. Okay, on how the ions accelerate in between the rods. Okay, thus only ions of a particular mass can be observed at a given oscillation frequency. Okay, so we determine the frequency, and then we can see the the signal, okay, that comes to the detector, okay, based on different frequency. Okay, by changing the oscillation frequency, other ions of other masses are allowed to hit the detector. Thus, a scan of all frequency gives a scan of all ions in the sample. Okay, so you can get all the ions that being ionized, okay, um, uh, in your sample. Okay, so this method is very good. Okay, next we go for the ion trap. So in the ion trap, we have a ion volume here, and then we have also the source length, and it will pass into this compartment. Okay, so this is the Enzel lens and central elements. Okay, and here is the first element. Okay, and then it will go to the trap ring electrode. Okay, so here is the trap ends cap. Okay, so this method use electric field for the separation of the ions by mass to charge ratios. Okay, the analyzer is made with a ring electrode of a specific voltage and grounded and caps electrodes. The ions enter the area between the electrodes, okay, between the electrodes through one of the end caps, through the one of the end caps. Okay, after entering the electric field in the cavity due to the electrodes causes the ions of certain mass to charge ratio values to orbit in the space. Okay, as the radio frequency voltage increase, heavier mass ion orbits become more stabilized and the light mass ion becomes less stabilized. Okay, so it will cause them to collide with the wall and eliminate the possible of traveling uh, and being detected by the detector. Now we go for the next one, time of flight, TOF. Okay, so this mass analyzer, okay, implement the separation based on the kinetic energy and velocity of the ions. Okay, so ions travel down field free tube separate according to mass. Light ions arrive first, heavy ions arrive later. So that is the concept. Unlimited mass, so basically you already know that time of flight doesn't have limited um, mass range. Okay, uh, however this time of flight is very poor in resolution, but it's still good. Okay, but we can use it. Okay, and we this method also poor sensitivity. Okay, so we have the drift tube here. with a certain length, okay, and here is your sample, and then it will go directly to the detector, okay. So in these tubes, okay, and the molecule will move, okay, and separated, okay, based on the mass of the molecule ion, okay. So now we go for the next part of a mass spectrometer, the application. So basically, the purpose of using mass spectrometer is basically to identify pure compounds. Okay, basically we will elucidate organic compounds. Okay, and this in order to perform this analysis, okay, they will determine the M plus, okay, the nominal M plus peak, and other signal, okay, that will tells you the molecular weight of the compound, okay. Okay, next, the exact mass to charge ratio can give also the stoichiometry, but not structure. Okay, so basically when we want to determine the structure or elucidate the structure, we will use the NMR. Okay. Okay, then next is the fragment peaks give evidence for functional group. So basically, instead of using FTIR, which is a less sensitivity, you can use you can use a mass spectrometer, okay, to give evidence for a different kinds of functional groups in the sample. Okay. Okay, next, we have also isotopic peaks can indicate presence of certain atoms. Okay, so in this case, we can also determine a variation of atoms. Okay, that might present in the sample with similar properties or more close similar size, okay, like chlorine and bromine, okay. So this can be differentiated by using mass spectrometer. Next is isotopy ratios, okay. So for the isotopy ratios can suggest possible molecules, okay. And next is by comparison with library spectra. Okay, so what we can summarize from mass spectrometer? Okay, so this instrument is actually one of the most powerful analytical tools. Okay, which very sensitive and range of ion sources for different situation, different purpose. Okay, elemental composition for a small and large molecular weight. Okay, especially biomolecules like protein. We can determine all those things. Okay. Next, limited structural information. Okay, sometimes it's not very clear because due to different reason. Okay, so we have a very limited structural information. Okay, in mass spectrometer. Okay, so for the mass spectrometer also we can use for a qualitative and quantitative analysis. If you have a sample a mixture uh, in your sample, then you can use this instrument. Okay, so um, if you want to determine the composition of solid surface, so we can simply use this mass spectrometer. Okay, and also the isotopic information. Okay, so for mass spec, there's a drawbacks that you need to know. Okay, that this instrument is very complex, and there are many factors that may disrupt your analysis when you use a mass spectrometer. And this instrument also very expensive, but a very high resolution. Okay. Um, the structure of the molecules or ion, okay, ion molecule can be detected, can be interpreted, but indirectly. Okay, so you need to understand all the experiment before you can run by using mass spectrometer. Okay. Next, complex spectra or fragmentation for hard ionization sources. Okay, so basically, when you use hard ionization sources, you will get more fragmentation. So this is the things that always occurred when you use hard ionization sources. Okay. Next, simple spectra. Okay, so for the simple spectra, when you use soft ionization sources. Okay, so that's all for chapter 5 about mass spectrometer, and thank you for your attention.